Welcome back, everybody. This video we're going to be talking about functions and function notation, how to evaluate functions, and we'll look at some graphically. First one here, what's the value of f of -1 when f of x equals 2x plus 2? So f of x here is a simple function notation. We can almost think of that as y. So if you want to think of this as y equals 2x plus 2, it's basically conceptually the same thing, just a notation issue. So when we say f of -1, it's saying put -1 in for x into the function. 2 times -1 is -2. Here we're adding 2. -2 plus 2 gives us 0. So the answer to the problem is when we plug in -1 to the function, you get a value of 0. You can sort of think of this as xy. We could actually plot that coordinate on the xy plane where x is -1 and y is 0. It's another way to think about it. Next, let's look at a function graphically. It's a linear graph. And we could find the equation of this, but we just want to find the value of the function at -2. So all we need to do is go to -2 on the x-axis, follow it up to the y value of the line, and then notice, oh, the y value here is 2. So whatever this function is, let's call it f of x, whatever the equation is. When I plug in -2, I get a y value of 2. And once again, as we showed on the previous problem, you can think of it sort of as coordinates -2, 2. And that's what we see right here, this coordinate right here, -2, 2. But the actual value of the function that we're looking for is 2. Next, we're going to talk about something called the vertical line test. The vertical line test says whether a graph of any particular graph is a function. We call these relations. A relation is simply a set of ordered pairs. So you could also think of these lines here as just an infinite set of ordered pairs. And we're going to use this thing called the vertical line test. Let me create a vertical line here. And if you think, I like to think of a vertical line as a scanner. And anytime you've scanned a document, or you go to the grocery store and they scan your groceries as you check out, just think of it being scanned across just like this. And the way the vertical line test works is if you're scanning a vertical line across a particular graph, and if the vertical line touches the graph at more than 2 or more places at the same time, then the relation is not a function, but rather it is just a plain old relation. Okay, look at this first one. It's a vertical line lined up with a vertical line. All of these points right here, it touches actually an infinite number of times. So we would say this first one definitely is not a function. All right, let's look at the third one here. I'll skip over here. Notice as I scan across, it is touching at more than one place. In fact, it's touching at 2 places at any given time. Yes, it's true at the far left it only touches once, but you have to scan it across the entire one. Alright, we're going to say this is not a function. Well, if it's not a function, what do you call it? You would just call it a relation. And over here we have the circle. Notice as I scan across, it is touching 2 times throughout. So again, we have another not a function. So hopefully that second one is, and you can see as we scan it, kind of that V shape. That would be an absolute value function, by the way. But as I scan across, it's only touching 1 time. It's only touching 1 time. So this second one, actually is a function. And the true definition of a function, for every input, there's a one and only one output. The vertical line test is a graphical representation of that. Here's 4 examples of relations, and just a set of ordered pairs, a finite number of ordered pairs rather than an infinite number as the previous one was. Let's get our vertical line drawn again. Alright, vertical line test. Starting over here, I'm going to scan it right here. Here's it's touching. 2 dots are touching. We only want 1 to touch. Third one here, one time. Third one, we seem to have a function here. Notice as I scanned it across, only 1 dot at any given time was touching. 1, 1, 1, 1. Let's check the second one. Nope, we're touching twice here. Scan a little further, we touch twice again. Alright, looks like, okay, looks at the first one. One time. We get to the middle, these 2 dots right here are touching. Yep. So all not a function, not a function, not a function. The third one is, because it passes what we call the vertical line test. Alright, and then lastly, what's the function rule for the line? Basically, another way of this question could be asked is, what's the equation? What's the equation? Alright, so let's start out by looking at it as an equation. We're going to use y equals mx plus b as a model. The y-intercept looks like to be -2, so we know that'll be our b. And then figuring out the slope, let's go from one point to another. Let's see, so go from this dot to this dot, the blue dot. Looks like we're going down 1, 2, 3, and to the right 2. Down 3, right 2. That means our slope is -3/2. Negative because it's going down. So there is our slope number, the m number. We have x, we have equals, we have y. Now to make this in function notation, I'm just going to write the same thing, but then instead of y, I'm going to use function notation, f of x. And there is the function rule for the line. Meaning, to find the y value, anytime whatever you do, whatever number plugs in for x, multiply by -3/2 and then subtract 2, and that will spit out your y values. Thank you for watching.